Today we have a presentation on vCenter configuration using Ansible and Jenkins. Dave, Thomas, and I have been recent friends. We've been discussing using Terraform, Ansible, Jenkins, Packer, any number of different technologies for the purposes of vCenter configuration. So I made him a deal that if I gave the presentation on Terraform that I gave to the CNI technical group a while back to his group, would he come over and give the presentation on using Ansible and Jenkins, do the same sort of configuration management. Dave, I'll let you take it away.
Okay, great. Well, I appreciate Justin for that introduction, and I appreciate everybody coming in, watching me present and demo on Ansible and Jenkins in our vCenter configuration, or how we configure vCenter, I should say. So we had had a discussion with management probably about the end of 2019 last year, and they really wanted to push to automate everything, more specifically getting all our infrastructure as code. We have the initiative to get at least 50% of it in code by the end of 2020. So that's where this Ansible and Jenkins and all this kind of stuff kind of flared up, and that's what we're going to be talking about today. So let me kind of go over the agenda here. I'm going to do a quick introduction of myself. We're going to talk about an on-premise cloud, why we still have vCenter. We are a cloud-first initiative brought through the C-levels, and they want to go cloud first, but it does make sense to have an on-premise data center as well, and we'll kind of go over that. Talking about the automation of Ansible, inventory strategies. It's a little unique with the vCenter versus your traditional inventory of VMs and physical hardware and things of that nature. Introduction to Jenkins, what it is, how we use it. A little bit of the challenges we've had with code. We're going to go into a demo, and questions. You're definitely going to ask questions during the presentations, or if you want to wait till the end to ask questions, we'll have a time at the end to also answer any questions that you might have. So my name is David Thomas, virtualization engineer with the Parsons corporate team. We do support some of the projects that came from the legacy Polaris Alpha environment, along with a lot of the corporate assets and getting merged into the Parsons corporate IT world. So I started with EOIR Technologies back in 2001. I was on the systems administration team. I was probably about employee number 70 or so. So it was a pretty small company. We did eventually grow to about 450 employees, somewhere around there. And there was only 3 system administrators. There's me and 2 other folks that pretty much had the keys to the kingdom, and we ran the entire network, all the desktops, anything you can think of IT related, it fell on our shoulders. So a lot of stress and a lot of responsibilities. In about 2015, Arlington Capital came along. They're an investment company that purchased EOIR along with numerous other companies like Proteus, ISS Inc., and ultimately formed Polaris Alpha in 2016. Merged all those companies together to about 1,500 employees, and went from a team of 3 to a team of about 30 or 40 on the help desk and IT team, networking, just a whole bunch of different types of groups. So it was a little bit different going into an environment that had so many folks, so many coworkers that and my peers that I work with on a daily basis. Didn't have the keys to the kingdom anymore, which is fine with me because it takes your stress levels down a little bit. If someone has something wrong with Exchange, you go to that group. And then we were acquired by Parsons around the 2018 timeframe, and I fell onto the virtualization team with vCenter and our on-premise data centers. And so that's kind of my evolution of my journey and who I am. So let's get right into it. The public cloud, or say like AWS, Azure, Google, is kind of the way that not just us, but the entire industry is going towards. And we've definitely had a stance of cloud first. I was on a town hall meeting earlier today. Stu Kippelman, our CIO, he's a big cloud person that pushed all new code that's going to be developed is going to be for cloud use. And when I say cloud, I'm saying public cloud, because there are private clouds such as what the vCenter is and VMware and things of that nature. There is definitely perks to having a private cloud and a use, because we are cloud first, but we're also cloud smart. And so some of the advantages of having being on a public cloud or a private cloud, I should say, is we have the current infrastructure already in place. So we have an on-premise footprint, and the hardware is viable. We still have service contracts with it. So it makes sense to utilize that hardware. Another thing is set costs. You have no surprise bills. I mean, you know what your costs are. If we have a 2 or 3 year service contract, we have the hardware there for the next couple of years. We have a built-in cost. It's already baked in. We don't have to worry about, 1 month is $50,000, another month we're $100,000, or I mean, you might get that surprise bill. It could be $1 million. You have no idea. I'm sure there are some guardrails in place and things of that nature to try and hone that in, but there are no surprise bills. Another thing is a lot of the code that we have, I won't say a lot of it, but some of the code we have was architect for private cloud. And it could be a big undertaking to rewrite that code for a public cloud. Again, Stu did mention he wants to make sure that everything from here on forward is developed for a public cloud use, but those are some of the benefits and the reasons why we still have a private cloud. I could definitely see in the future this footprint shrinking quite a bit to ultimately be everything in the cloud, or just having a few things on premise and really shrinking this footprint down. But in the meantime, we do have this vCenter and we do need to maintain it. So going in with into Ansible a little bit. The reasons why we chose Ansible, the first thing we need to do is look at these tools. We are fairly new to the automation of things. I don't come from a huge programming background. I've done some scripting, some web scripting, some web stuff, a little bit of Power CLI, things of that nature. But when it came to the automation of infrastructure, our team was fairly new at it, and we didn't know exactly where to start. So we did what every good engineer does and go straight to Google. So we Googled some of the tools out there, and we found that there's a ton of them. I mean, there's Chef, Puppet, Ansible, Salt, Terraform, Power CLI. I mean, the list goes on. And so we ultimately did narrow it down to Ansible and Terraform. Those are the two that we said, okay, we really want to kind of find out what of those two tools are going to be best. And we kind of narrowed that down by just talking with people and doing searches and our own research. And as Justin mentioned, he has used Terraform. I have used Ansible. We did kind of have a throwdown, I should say, in our group. We wanted to showcase what Ansible can do, showcase what Terraform can do. And so it was me and one other coworker, my manager, Chris Howe. He took Terraform, I took Ansible, and we kind of did a little demo on what it would take to spin up code inside of our environment. And the biggest takeaways we got from that was, one was declarative and one was procedural. Terraform is declarative. So declarative is really kind of knowing the environment. It has like an exact blueprint. So if you spin up 5 VMs and say, Terraform, I want 5 VMs, it's going to give you 5 VMs. You tell it, hey, I want 7 VMs. It's going to give you 7 VMs. Even though there's 5 there, it's going to know there's 5, and it's just going to give you 2 additional VMs. Ansible is more procedural. It'll learn the environment when it needs to. It doesn't necessarily know the environment at its given state. And it'll make choices and decisions and change your environment based on the current set of instructions or that specific playbook that you're going to be running at that particular time. So for instance, if you have a 5 VMs and you say, hey, Ansible, spin up 5 VMs, it's going to spin up the 5 VMs. If you say, I want 7 VMs, so if you tell Ansible to spin up 7 VMs, it's going to spin up 7 additional VMs. So you're going to have 12 VMs. You'll have to know that you only want 2 additional ones to make 7. So this is the biggest difference between declarative and procedural. What's pretty unique about Ansible is you can do some declarative stuff. So when you get into the inventory and host files, you can actually tell it to learn the environment and make changes based on those things. So for instance, I had the 5 VMs. 2 of them are set to give me a dynamic IP address, and 3 of them are set with a static IP address. And I want to change them all to DHCP. Well, I can tell Ansible I can go into a host file, and each VM will have its own host file, and I can go and tell them I want DHCP. Ansible will go in and learn and say, okay, well, I see the 5 VMs here. I see that you're DHCP, so you're good. You're DHCP, you're good. Okay, these next 3 are static, so I need to change those to DHCP. So that was the biggest takeaway. We're really trying to find that declarative language, but Ansible really spanned the 2. So that was a check in that box for pretty much both languages. And then we looked at other teams and finding out, who has a lot of knowledge in this. And our site reliability engineers, they're a heavy Ansible shop, and they have tons of experience, and they have code that we can already leverage. So we talked to them, and they're more than willing to help us, and they've been really great in helping us implement this IAC journey that we've been going through. And then our last decision is really just the easy use. So the language that Ansible really ingests is YAML, and Terraform uses JSON or JSON. And we just found that both of them are fairly easy to use, but YAML is just that much easier. It's very human readable. It's very easy to write, to read, to learn. So ultimately, we went with Ansible and using YAML. So now that we decided on Ansible, we needed to kind of learn how to execute these playbooks and how you use Ansible. And the playbooks it's not the only part of Ansible. You can do ad hoc commands and things of that nature, but it's a core feature of Ansible, and it tells it what to execute. It's like a playbook is like a list of tasks. It's just a to-do list essentially, and it's sequential. So if you have 5 tasks in a playbook, it's going to run the first task and the second and the third and fourth, and it can get a little bit more intuitive. You can do some pre-tasks and post-tasks and things like that. But for what we're doing and just kind of a broad overview of Ansible, we're just going to stick to tasks right now. A sample playbook you'll see here is you have your hosts, and I kind of mentioned hosts earlier. You can create a host file. You can create multiple host files. You can group host files together. So when you list hosts at the top, you're telling it where you want to target. And this specific one is all, and all is a default group for all your VMs. So, or switches or whatever hosts that you have out there. You can break them down individually, so you can target an individual host, or as I said, you can do groups of hosts. So if you have multiple databases and you want to target just the databases, you can say maybe databases or web servers, and you can group those all together. And that's done in our inventory, and we're going to get that here in a little. So we're using our local connection, gathering facts. Not gathering facts in this particular playbook. That's if you want to gather more information about your target hosts and things of that nature. And then we get down to our tasks. So the first task we have here, we only have the one task, and we're going to name that task configuring data center. And then we're going to call the module. VMware Data Center is a module. So the VMware Data Center is a Python module. It's written in Python. It uses a lot of the APIs for vCenter. Normally in Ansible, it uses like SSH keys, and you would SSH, you use your username, password, you can use the keys, and you would log into the host and you modify it this way. With VMware, it's a little bit different. We have the Python modules we call, and we use the APIs, and we log in with the username and password, and we target a specific host name or a vCenter name. These are the Jinja 2 syntax for Ansible, or for YAML, I should say. These are the variables, and the host files are where those data or the variables, the values of those variables will lie. Down at the bottom, you'll see data center name. This is hard-coded in. You can hard-code it, or you can variabilize this as well, and you can store those variables inside of a host file. And then the state, we're just saying, hey, we want this to be present. So if it's not there, it's going to build it. If it is there, it's going to skip it. And then another thing, another value of state can be absent. So it'll either remove it or not build it. So this is kind of what the console output looks like. So to run a playbook, you do Ansible-playbook, and then you actually call the playbook. In this example, it's portgroups.yaml. That's the name of our playbook. The playbook will have the pretty much the skeleton of how you want your infrastructure to look, and then you can actually, right now we're doing it for lab VDS, but that's the host that we're using in this example. But you can do it against all. You can do it groups. Just like I said, you can target any particular host. This one we are targeting lab VDS. This output is actually ran inside of Jenkins container. We'll get to that a little bit later, but we do need to install some dependencies for our container. So that's what that first line is doing. The next couple of lines is actually going through the host file and is configuring those port groups. So So you can see that if there's no changes, it just says it's okay, and it's labeled in green. And so this particular change in this host file, there's nothing done. It learned it and says, hey, you're good to go. The next one is an actual change. The change in this particular one, you'll see the port group state was present. It actually built it, and that was the change that it did for here. It did not exist, it built it. The next one was okay, and these last two changes, I changed it to absent. They were currently in the vCenter. I told it, hey, let's remove it, and it actually went through and removed it. So it gave us our desired state based on the code that we had in our host files. And you can see the play recap. We had 2 that were okay, and then 1 task that was changed. We had this particular task that was changed here. Or I should say this host file was changed in 1 task, and it was okay in 2 other tasks. So earlier I explained that Ansible uses YAML. So just to kind of run through what YAML looks like and kind of give you a definition. So this is the Wikipedia definition. YAML it's a human readable data serialization language commonly used for configuration files and in applications where data is being stored and transmitted. So what we're really using it for is the data storage. We are storing our values in a YAML file and labeling those as hosts. And those hosts are what's going to make our environment unique. Files are both case sensitive and white space sensitive. So we'll kind of get into the white space of it here in a little bit. They all start with the dashes, 3 dashes, and they all end with 3 periods. And the way we're using it pretty much is our key value pair. So an example of it, again, we start with the dashes, end with the dots. And this particular example is a list. So it's just a dash red, dash blue, green, black, and it just lists out values. The next one is the dictionary format. We have our item called David, and David has some attributes to him. He has a name, he has address, and he lives in the state of Virginia. You'll notice the white space here. Again, like I said before, it is white space sensitive. White space sensitive. So when you move underneath David and you put the spaces in, it's telling YAML that you want these specific key values to be associated with David in a dictionary format, whereas before you could see each one was an individual list. And then you can get a little bit more complicated. You can add dictionaries with lists, and you can just nest everything all together. You can see we had, David now has skills, and he has a list of skills. Again, these are white space sensitive, so these skills are dictated through the white space. If I change that, it will throw errors, and they all have to have the exact same white space. So we're getting into the inventory now. So the inventory, before I said, it uses hosts. You can use groups, or you can use individual host files. And this is the directory structure we'd use. You would have a group vars directory, and you'd have a host vars directory. And underneath there, you will have the groups or the hosts. And the way it's laid out, I'll kind of zoom in so you can see this a little better over here. You have your all group. That is the group that is by default. You have all. Then you have children of that. You have vCenters. If I have multiple vCenters, you'll have them listed underneath here, like lab vCSA01 is our vCenter. If I had another one, it would be lined up right down here underneath all of this data, kind of like where you have lab clusters down here, but we'll get into that. So underneath here, we have our lab data center. From underneath our lab data center, we have our hosts, and we have, our lab clusters, and we have our lab networks. And then from here, we actually have our host level at the lab cluster. I had mentioned earlier that it's a little bit unique with vCenter because normally you think of hosts as a VM or a Cisco switch router or like a Palo Alto firewall, which are generally either physical or some sort of like operating system like a Windows VM or a Linux VM. Here, we're actually breaking it down, and we're using the broken down aspects of our vCenter to be the host. So our clusters inside of our vCenter is actually our host. our lab switches, or not our lab switches, but our network switches, our VDSs, our virtual distributed switches, they are the actual hosts inside of our vCenter. So it's it was hard for me to wrap my head around it at first, and it does get a little easier, but so it just goes and shows you the scalability and how easy it can actually be to use Ansible and how powerful it really is. So why do we have all these groups and why do we have all these hosts? Again, like I said, all of our variables that define a host are in the host file. And that host file you would put in the host directory. Anything that's a group would be in the groups directory. If I had a lab that is named lab cluster 1, I would put that variable inside of the actual lab cluster 1 host name or host file. So anything that makes it unique is going to go in the host file. Anything that shares a common attribute, you want to put it in a parent file. And what that does is if I say I have DRS. So DRS is our distributed resource scheduler. It allows us to automatically move if I have 5 hypervisors in one cluster and I'm overloading one with a bunch of VMs, it's just really taxing the VM and the CPU, and all these other hosts are kind of running idle. They have tons of resources to spare. Well, DRS will automatically move those VMs over to these hosts and distribute that load. So we want to make sure we have that turned on all the time, and we put that in a parent group because it's common amongst everything. We want that value to be same for all of our hosts. There are going to be times where we're doing some maintenance and we don't want a host to have DRS, whether it be a hardware issue and we're trying to troubleshoot it and we just don't want any hosts going on there, but we still want it in the environment. We can actually take that value that's in a group that's a parent, and we can move it down into the host file itself. So I can take this DRS behavior fully automated. I can put it down in the host file, the lab cluster 1, and change it to manual. And if you can see up here, it says last in always wins. So it loads all the group variables first, and then it'll load your host files. That was put in last. So even though there's a parent variable that has a value, whatever's in that lowest or that last variable, that's going to win. So it's going to override and supersede anything that's a parent. So moving into Jenkins, we've kind of explained Ansible, YAML, and now we're running into Jenkins. So what is Jenkins? So Jenkins website says it's an open source automation server which enables developers around the world to reliably build, test, and deploy their software. Well, the key software. It is really designed for a software build and for a lot of developers to leverage some of the stuff that it does. Jenkins will take your code and it will run it in like a container and push it out into your environment. What we're using it for is really for the ability for a cron job. We will take code and say we want it to execute every single day. So we have a desired state. If somebody went into and changed DRS manually, and we really want it to be fully automated, well, we have a script that every single night it'll go back and make sure that everything is turned to fully automated unless otherwise specified in a host file. But it's really to help prevent any types of how we're using it is to help prevent any configuration drifts or anything that was done in the GUI that inadvertently didn't get changed back so that we have that desired state. So if anyone's familiar with cron, it's really just a scheduler that will kick off a task at a specific time, weekly, monthly, daily, however you see fit. But we do also have scripts that run in Jenkins that are on demand. It's not necessarily on a time schedule. We'll just run it whenever we have new code that we need to push out at that particular time. So Jenkins uses Groovy, Groovy scripts. It's kind of it's a Java syntax. So if you're familiar with Java, you'll probably be pretty comfortable with Groovy. I'm not going to go too far into it, but I do want to kind of showcase and display what Groovy looks like. parameters. So in this particular case, we're setting the host and where we want to limit that or target a particular host or a group var or host var. Then our cron job here, this is the beginning of our pipeline. It's just saying that we're going to go every day between the hours of 12 a.m. and 2:59 a.m. So it'll kick off that job between those times every single day. And then it gets down into the actual node. This is when we say node, this is the container. So Jenkins will spin up a container. Containers, the reason why I use it's ephemeral. It's not going to be there for very long. It's going to just spin it up. So we don't want to necessarily use a VM. VMs, we think of something a little bit more long-term. Containers, we think of something that we can just kind of destroy right then and there when we're done with it. So we spin up a container. We dictate that we want some notifications. We have Ansible bring in our inventory. We create the first stage of our pipeline. And this is checking DRS and making sure that's in the desired state. It is pulling in some credentials from Jenkins Vault. And then it is passing them into our playbook. And then the playbook that we're using is our config vCenter.yaml. We have tags. Tags are, if you don't want to use every single aspect of your code, you only want to use a small portion of it. For instance, this right now, we only want to check DRS. We don't want to create a data center. We don't want to create clusters. We don't want to create switches. All we want to do is target DRS. You can use tags within your code to be able to target a small specific portion of your code. So that's why we use the tags in this particular example. We're limiting it to the tags. And then it is limiting it to a specific host file. And that host file is a parameter that we gave Jenkins up here. And that is variableized up here. And we'll tell Jenkins when we kick the job off which host we want to limit it to. And this down here is, can't really see it too well, I'll zoom in. And this is just Jenkins, what the GUI looks like. This is the console output. And now we will get into some of our challenges we had with code. Ansible doesn't necessarily do everything, especially since there's modules that are built in Python. These Python modules were built through either VMware or some sort of partner of VMware. And they do have some limitations. Some of the things that we are limited, they don't have modules on how to update the vCenter, how to build baselines, giving permissions to users or groups, things of that nature, along with ESXi host preparation. It doesn't have much ability to be able to do that. So, I mean, we could go in and build our own Python modules. I personally am not that advanced, and I'm sure there's some people in the company that would probably be more than willing to take on that, but it's a pretty big undertaking, and there are other resources that we can use. For example, PowerCLI. That's kind of our second choice in the VM world. It has tons of commandlets, over 700 commandlets just for PowerShell. So PowerCLI is a plugin for PowerShell, and it has tons of commands that we can leverage. And we definitely said we want to be Ansible first, and then anything we can't do in Ansible, we kind of start using PowerCLI. We can call these PowerCLI scripts through Ansible. But those things that we weren't able to do before, such as updating vCenter, ESXi host preparation, things like that, we can do in PowerCLI. So I've talked long enough. Let's go ahead and get into the demo here. So we're going to kind of showcase and let you know and show you how it actually works. And we'll go ahead and put everything to the test.
Hey, David Thomas.
Yes.
Hey, so we have some last minute maintenance we had to do on one of the clusters. Were you planning on doing the DRS code?
I can definitely not do that.
Okay.
What I'll
I don't know if you have something else you want to show, or
I'll target everything in the host. I won't do the DRS. I will target the lab clusters and building a cluster, building a switch, things of that nature then. So we'll just pivot a little bit.
Oh, okay. So you're targeting the lab?
Yeah, I'm just targeting the lab right now. Well, that one particular job does target the entire environment, but I'll target the lab. So I'll make sure that we do.
Okay. Yep. Great. Thanks.
Yeah, no problem. All right. So let's go ahead and get started here with this demo. So let me bring up just situated. So we have our lab here, and it has a couple of clusters, lab cluster 1, lab cluster 2, 3, 4. It has a couple of switches in here, a couple of port groups. If you're not familiar with the VMware and all the different clusters and port groups and networks, don't worry about it. We're really just showcasing how Ansible can be used to configure a lot of these types of things and how easy it is to use and how intuitive it is. So the first thing we're going to do is if somebody came in here and we say we had a lab cluster and somebody inadvertently deleted something in the GUI, and I'm going to delete this lab cluster. So the resource pool in the lab cluster was just deleted, and we have a script that will actually build out those clusters for us. So let me come over here to IT Jenkins, which is our Jenkins server for our corporate side. So I'm going to click on our virtualization tab. Actually, I'm going to blow it up a little bit. It's a little wonky, kind of shrunk down. This is a little bit better. Okay, so I have a job here called virtualization configure vCenter. I can click on this. You can see the build history on it. It has had some failures in the past. It has only one stage in it. Again, like I said before, you can use Jenkins for a multitude of ways. We're not really leveraging all of that. We don't have much of a need for right now. In the future, possibly. But you can do things like testing code, things of that nature. You have multiple stages, build a little bit of logic into it. So it can get pretty intuitive and pretty neat. But for this example, we're just going to be building just one little pipeline with one stage. So we're going to build it. We're going to build it with parameters. And by default, everything in here is null. So somebody doesn't actually come here and build something and it's targeting a host. So there has to be some sort of user intervention with this just for some guardrails and some fail safes. So we're going to pull up our inventory. So this is our inventory. I want to target our lab cluster 4, but I don't necessarily want to target lab cluster 4. I want to make sure all our clusters are configured the way that it needs to be. So I'm actually going to target the group above it called lab_clusters. And what this is going to do is it's going to bring in all the variables that are before it. It's going to target this particular host. So anything below it is what is going to run this playbook against. So it's going to skip the lab networks. So lab_clusters. Oops, my underscore is not working. Okay. All right, let me cancel this. I hit enter accidentally. Okay, so cancel that. So lab_clusters. And then tags we had said earlier, you can target a specific tag, whether I want to build something, if I want to just check the DRS, the EVC mode. There's tons of tags in this particular playbook that I built, but I want to make sure that the environment, all these lab clusters, it runs through the entire playbook. So I'm not going to have any tags in there. So let's go ahead and build this. So we targeted the lab clusters, and you can see it's kicking off this stage here. I'm going to click on this blue bar. It gives us the progress, a real-time progress of it, and it gives us a console output. So I'm going to click on that, and you'll see the console output. So what this is doing is pulling, I did have a Groovy script that I built. So it's pulling the Groovy script, and it's going to do everything based off of that Groovy script. And it's coming down, it's going to start building the container here in a moment. And then once it pulls the container, it is going to, there are some default playbooks that it needs to use to provision the environment. So it's, it mimics production. So it's going to run some sample or some generic playbooks against this container to make sure that it's all staged and ready for my code. You see it's going through all these different tasks, and these are Ansible playbooks that it's running against. So it just staged the environment. So now what it's going to do is going to check out my code, and it's going extremely fast. It's going to set my inventory. So I have my own specific inventory, and it's called Ansible infrastructure, Ansible Inv infrastructure. is going to tell it to, hey, we want to set the inventory to use that particular inventory. So I'm not using someone's inventory for like the SRE's inventory or anything like that, just pulling in my inventory. And then down here, it actually, you'll see this playbook kicks off, and it does my playbook configure vCenter.yaml. It limits it. So the -L is limiting it to the lab clusters. So it's not going to all or to a vCenter or a specific host. It's going to the group called lab clusters. And then we are piping in, or including, I should say, not necessarily piping in, but including extra variables. And these extra variables are the vCenter username and the vCenter password. Before I had mentioned that Jenkins has a vault, and these are the credentials that are in the Jenkins vault. It's just a service account that we have, and it mimics the same permissions that I have to be able to run these commands. So the first task it does, it just grabs one generic, just one playbook, and I have a task in there that sets up our environment. There's some playbooks that it ran beforehand that is just a generic set of playbooks that will stage the environment, and it will make the environment production ready. Not all those. That environment doesn't have all the dependencies that I need for my environment. So vCenter and Ansible, it requires a plugin or a vCenter module called PyVMami, and it may be pronounced differently to some other people, but I call it PyVMami, and it's installing required pip packages. And so it's going to just take one host, and it's not using any of the variables, but it has to attach it to one of the hosts, and it's installing it. So it's staging our container to have those PyVMami module installed. So the first thing it's going to do, it's going to go through all the different tasks. Like I said, these are the tags that I had: configuring the data center, configuring the clusters, configuring DRS, HA. I did not limit it to a specific to a specific tag, so it's going to run through the entire playbook. And from here, you'll see we don't necessarily need to configure the data center, so that's okay. We configured the cluster. So if we go back over to the lab data center, you'll see that that lab cluster 4 is now there again. And that was built through that particular instance in this playbook. We configured the DRS, so we turned it back to fully automated, configured high availability. We changed the EVC mode. See, I guess all changed for just the cluster 4, because 1, 2, and 3 were already set. It learned that and said, I don't need to touch it, and it only changes to that one lab cluster. It built the resource pool. You'll see it's listed underneath there. Didn't have any folders that I needed to configure. Everything was okay. The switches, the port groups, snapshots, we did put a little bit of logic in there, so it just skipped over these. It didn't even try to run anything on there, just because it knew it wasn't a switch, it wasn't a port groups or anything like that, so it just skipped it. One person did ask us, is this version 6.7? Yes, it is. It is version 6.7. We upgraded to that late last year. Early this year, we got it all fully switched from 6.5 to 6.7. Just in time to go to 7.0, but we don't have too much a roadmap for that just yet. So does anyone have any questions so far about what we have done and how we've used Jenkins, how we've used Ansible? So we are not using like Ansible Tower or anything like that. We're not using the command line in this particular instance because we want to try and make it accessible to anyone and everyone. So we put it in Jenkins jobs so that if it's not me doing running this playbook, it's someone on my team. They don't have to go and learn how, like, what is this playbook, look at the README files and try to figure out the playbook itself. Even though it's pretty intuitive and pretty easy to learn, we want to keep everything in Jenkins and everything in one centralized location. All right, well, can anyone hear me?
Yeah, I'm here. Sorry.
Okay, I just didn't know if the video cut out. I saw somebody saying their audio or the video paused.
No, that was me. It's a little unfortunate because I record these from this machine. I did miss a little bit of the last little bit of your Jenkins bit. Anyways, thanks for your time today, David. I appreciate it. This was enlightening for me. I see, I'm on Virtually Ghetto and a couple other places as well.
Yeah, that's a great resource. I've gone through there and I've used some of the stuff. Some of the stuff that we're going to be using Ansible in the future, I kind of want to showcase it or have some use cases for Ansible is our NSX firewall rules. So we're going to be building out an NSX environment, NSXT, and that's going to be using Ansible for that. Our firewall rules, right now we'll be using Ansible. There's a strong use case for Terraform in our firewall rules, but I think we're going to tackle it with Ansible now and kind of decide later if we want to switch to Terraform. But we have a strong use case for the firewalls as well.
You did get another question from Ryan there. He wants to know why Ansible instead of Terraform for the firewall rules.
Well, so and that's what I was saying. Ansible has a very strong use case for firewall rules. Ansible is it's more procedural. Terraform is the declarative language, and you can set your firewall rules in Terraform, and it will make sure it's the desired state for every single firewall. It gets a little unmanageable if you have a ton of firewalls and you put them in like host files and things like that in Ansible. So that's something we are going to look into, whether Terraform has a stronger use case with the firewall. We haven't quite got down that road yet. We are slowly building out the NSXT environment using code. And once we get to that firewall aspect, we may change gears and go Terraform. We haven't ruled it out completely. We do have an Ansible first kind of motto inside of our virtualization center, but just like when we have our cloud first, we got to be cloud smart, we got to be Ansible smart. If we know Ansible is not the right tool and Terraform is going to be a better fit, we'll probably go down that road as well. So I appreciate you commenting on that, Ryan, and we definitely are not ruling Terraform out by any means.
So there, I want to add something. This is Chris here. I work with DT. So there's a question about why go Power CLI instead of doing something like Python or maybe some other language to do API calls. There's a really interesting use case for using PowerShell modules. And because it's object-oriented, I know PowerShell gets a lot of hate, but we're actually starting to write some code for our Nutanix environment. Nutanix does not have any kind of Ansible modules or anything like that available. So we're writing some code using PowerShell. And the reason why we're doing that is because we can literally call the state of the environment and get some of the functionality that something like Ansible gives us. And it's object-oriented. And so we recently, we're working on this script to build out a Nutanix cluster. And the way it works is it'll check the state of the environment against a configuration file. And if it doesn't match the configuration file, then it's going to go and change it according to the configuration file. And you think that would take a lot of code to do that? It's literally like almost 40 lines of code. So if anyone's interested in seeing how something like that works, I'd be happy to show it. But I think it's going to be proven to be very powerful.
Absolutely. Is there a Terraform provider for our firewalls? Yes, there is for NSXT or for NSX in general. All right. Let's see what. Oh. Leverage that capability specifically for vCenter. Yeah, so we have that role that I can provide you if you are looking at that role to be able to leverage those capabilities. I mean, the code is already written there. It's nothing proprietary about it. It's just very generic. I don't have any like PowerPoints or PDFs on how to specifically use the role. There's some README files or anything generally, just other than the presentation I gave today on Ansible in our environment. But I'm more than willing to share that role out. It's in our repo, and I can give you access to that.